Okay, we're taking a look at VFPM Practice Problem 4. I've started making a picture here. We've got a block on a frictionless table with a second hanging mass connected by a string over a pulley. So I've got two masses going on, one on the tabletop and one hanging down, and I'll get those drawn in here. Whoop, that's not the right shape. And then we'll look at what happens when they get together. So here's my picture. Here's my strings. I've got strings connecting the mass on the table to the pulley. Wow, that was terrible. To the string, to the pulley, to the one down below. Something like that. All right. We've picked some mass. All right, let's pick some mass. Let's again pick 3 kilograms here and 4 kilograms here, and then find the acceleration and the tension. All right, same scenario. We need to draw the forces in this picture. Right away, we know we have mg here, and a little bit less long, we have mg here. We also know we have the table balancing with the same thing up here, and there is no friction in the first round. We do have some tension. We know it's going to accelerate, so I know the upward force here has to be less than the downward force, and the same size on the opposite end of the string over here. All right, so we've got tension, tension, m3g, m4g, and normal. There's our forces. We know that the normal and m4g are equal. Question, let's think about force diagram. Check. Let's think about net forces. That's next. So on the 4 kilogram, the net force is just T. There's nothing else. The other two cancel. On the 3 kilogram, the net force appears to be m3g minus T. Again, I'm going to choose down as positive because that's the way this thing's going to go. I'm going to make this way positive. Okay, we got the net forces. Now let's write F equals ma. We're going to replace F net with F equals ma. So m4 of A equals T, and m3A equals m3g minus T. All right, so now we have written two equations, and now our job is to figure out the acceleration and the tension. So now we need to do some math. I'm going to combine those two. I've noticed that this one conveniently already is solved for T, so I'm going to shove it in the other one and combine the two. So here we go. I've got m3a equals m3g minus, and then I'm going to replace T with m4a. That's a 4. Doesn't look like a 4. Wow, that got worse. So here we have a tool that we now can use to solve for A. I'm going to pull the A over to the left side. M3A plus M4A equals M3G. I'm going to pull out the A and just solve all in one shot. So I have A, I have M3 over here, I have G over here, but I pulled out the M3 plus M4, and it ends up on the bottom over here. You'll notice this is just like the Atwood machine problem, except there's no difference of masses on the top. So there's our acceleration. Again, if we put a number on this, in this case, well, 3 on the top, 3 kilograms, 7 kilograms on the bottoms. This is going to be 3/7, the 7 because it's 4 plus 3 of g. So our acceleration is 3/7 of g. And again, if we wanted to find the tension, it might be easiest to pop it back in the equation for number 4. Tension equals m4 times a, so m4 is 4, so it's 4 times 3/7 of g, so it looks like 12g over 7 is our tension, something like that. So there's the A and the T. All right, quick breath. Okay, so now I'm going to go back and add the friction force, and we'll think about trying this again. So if we know there's friction, that's going to go back in the opposite direction, and it's not going to be as big as T. So I've got a friction force here, That's going to affect my net force on 4 to make it T minus force of friction. T minus force of friction. So then I get a little messier when we have to solve things. And this is the initial round of solving. Boy, we better clean this up a little bit. So here, if I rearrange equation 4, I get T equals M4A plus the force of friction now. And I have the other equation just like it is. I'm going to leave it alone. I'm going to replace FF with mu Fn, because that's hopefully a fairly familiar idea by now, the coefficient times the normal force. But we know the normal force is equal to M4G. So now we'd have M4A plus the force of friction, which is mu times the normal force, M4G, equals T. And now we're going to have algebra soup. So that's one equation. The second equation is still M3A equals M3G minus T. And if we really felt the urge, we could combine these two and solve this thing. Honestly, I'm not sure it's worth the time. M4A plus mu M4G goes in over here. You end up with a big mess. I'm not even going to take the time to solve it. You could, I could, but I wouldn't ask you on an exam to go that far. But certainly we would end up solving these two and come out with an expression for A in terms of M and G, but it would also now have the mu in it. But again, we're not going to take the time to work through that algebra. We could, but I don't think it's worth your time. All right.